Hey everyone, I'm Srishtika Neelakantam and welcome back to Ably's Quick Bits. In this video, we'll look at a popular feature in the HTTP world called Idempotent Publishing, what it's all about and how you can implement this with Ably. Now, the textbook definition of idempotence is that it's the property of certain operations in mathematics and computer science whereby they can be applied multiple times without changing the result beyond the initial application. Basically, in the context of HTTP, idempotence means that making multiple identical requests has the same effect as making a single request. Idempotence is very important for nodes communicating over the internet because the connections involved are often unreliable and it's hard to assess whether a message sent over this network to another node did in fact reach it or not. The message may have failed, the acknowledgement of successful reception may have failed, you just never know. So naturally, you end up resending the message just to be on the safer side. An easy way to deal with this would be to identify the messages in some way and eliminate duplicate messages from carrying on for further processing. Let's look at how Ably deals with idempotence. Consider a scenario where we have a REST client and a real-time client, both connected to the Ably data stream network. Now, of course, the real-time client is connected over a bidirectional duplex connection, such as WebSockets, whereas the REST client communicates with Ably via HTTP requests. Let's say we'd like client A to publish a message to client B via Ably's channels. It sends out a request to publish a message, say hi, which then is sent off to the recipient in real time by Ably. Now, perhaps due to the network failing at client A, let's say the acknowledgement about the publish being successful never reached back. So it has no way to know if the message in fact was published successfully or not. Obviously, the next best bet for client A would be to republish the message hi. However, we know that only the acknowledgement wasn't successful but the message was actually sent off to client B as intended. In such a case, a republish of the same message would cause client B receiving a duplicate message. We don't want this happening. Ably offers the idempotent REST publishing client option to prevent this. Enabling this client option allows the automatic publish retries done by Ably's client libraries to be idempotent in nature, allowing the Ably servers to discard duplicate messages following a failure such as a network fault. In version 1.2 onwards, this client option will be enabled by default. However, if you have your own mechanism in the client side to republish on failed or missing acknowledgement, then explicitly attaching an ID to the message object at the time of publishing ensures idempotency is still maintained. We'll look at an example of explicit attach of a message ID towards the end of this video. In this scenario, an idempotent publish of the message prevents the real-time client from receiving a duplicate simply due to there being a failure in the success acknowledgement reaching the publisher. There is a chance that the published message propagates from one region to the other. Let's look at how idempotency is handled when there are multiple regions involved. Consider a scenario involving two of the Ably's data centers present globally. Let's say our REST client is closer to the node in US West 1 region, so it's routed automatically to communicate with this region. Let's say our real-time client is somewhere far away and the closest node to that client is US East 1, and hence this client's communication with Ably is done via this node. The nodes themselves are connected to each other and communicate all the time. In this scenario, when the idempotent publishing is enabled, the EU West 1 node notes down the ID of the message published to it in its index. This message is then propagated to US East 1 node, which then notes down the ID in its index too. This helps in two cases. One, a republish of the message directly to EU West 1 would lead to a discard of that message as the ID was noted down in this node. And two, if due to Ably's smart latency-based routing at the time of republish, if the client A is now directly communicating with US East 1 node, the republish of the message there will also lead to a discard as its ID was noted down in this node's index as well, preventing the client B from receiving a duplicate message in any scenario. Another possible scenario is when client A publishes a message to Ably, say to EU West 1 in this case, but the acknowledgement never reaches back to the publisher. So now client A attempts to republish the message, only this time it is routed to communicate directly with the US East 1 node. Assuming that the recipients of the message are connected to both the regions, that is, client B is connected to US East 1, whereas client C, which is another real-time recipient, is connected to EU West 1. If the original publish was successful, it means that EU West region would have noted the ID of the message in its index to avoid duplicates. Whereas, due to the republish via US East 1, now even that node has the ID down in its index. So when both of these nodes publish the message to each other for recipients connected to the other one, the messages are simply discarded as they would be marked as duplicates on both of the regions. Let's now have a look at explicit ID attachment to the message in practice. As you can see here, this is all how you'd expect a regular Ably PubSub implementation to look like. We have a channel name being randomly generated and a REST client being initiated. Note that I've set Idempotent REST Publishing client option to true as I'm currently using Ably JS version 1.1. As mentioned before, enabling this option will ensure that automatic publish retries done by Ably's client libraries are idempotent in nature. Then from a user input, we publish a message onto the channel. Similarly, we have the real-time client connected to the same channel that we randomly generated before, which is subscribed to the messages that we're publishing using REST. And we just log these messages into a text box. Let's see how all of this looks like. As you'd expect, multiple publish of the same message makes the subscriber receive it every time. Let's go back to the code and edit the client to attach an ID to each message. After adding another field in the HTML to let the user input an ID, we can simply check for the existence of this ID and if so, attach it to the message object as an ID attribute. Let's add this to our log text as well so we can see what's happening. Now if we go back to the output screen and try and publish multiple messages with the same ID, the subscriber doesn't receive any duplicates. Any messages with a unique ID still get delivered normally. The complete code for this demo can be found in the description of this video. Make sure to check out the full documentation for this feature, which is also linked from the description of this video. That's all for this quick bit video. Hope to see you all again soon with some other interesting info.